Assalamu alaikum. Hi students. Today we will be starting our new topic, that is elimination reactions. In this series of lecture we will be discussing an introduction to the elimination reactions, that what are the elimination reactions, the types of elimination reactions, the conditions which favor the elimination reactions, and the expected products from elimination reactions, and the stereochemistry of those products. But before going to the elimination reactions, we will refresh our memory about different organic reactions we come across normally, that is oxidation reactions, reduction reactions, then come the amination, sulfonation, and so on. But the most important types of reactions, or main type of organic reactions, are addition reactions. In addition reaction, a group of atoms are added to an unsaturated compounds, and as a result we get a saturated compound. That group of molecule, or that molecule, may be hydrogen, that may be water, that may be hydrogen and halide, or that may be the halogens. The next important type of reaction in the organic chemistry is the substitution reaction. In the substitution reaction, one functional group or one group is substituted by another group. That is, the one group is replaced by another group, and as a result we get a new compound. The substitutions are of different types, like SN1 reaction or SN2 reactions. Then the third main type of organic reaction is the elimination reactions. As we have previously discussed, in elimination reaction, a group of atoms or molecules are removed from a saturated compound. Elimination reaction is a type of chemical reaction where several atoms, either in pair or groups, are removed from a molecule. Okay, these removal are in the presence of a catalyst, that may be acid or that may be base. But this can also happen at high temperature. When we heat up a molecule at high temperature, so it can lose a pair of groups, and as a result we get an unsaturated compound. It may also be defined as a class of organic chemical reaction in which a pair of atoms or groups of atoms are removed from a molecule, usually through the action of acids, bases, or metals, and in some cases by heating to a high temperature. Elimination reaction is mainly used to transform saturated compounds, that is, the organic saturated compounds which contain single carbon-carbon bond, to unsaturated compounds, that are the compounds having double or triple carbon-carbon bonds. It is the principal process by which organic compounds containing only single carbon-carbon bond or saturated compounds are transformed to compounds containing double or triple carbon-carbon bonds, that means to unsaturated compounds. The elimination reactions are distinguished by the kind of atoms or group of atoms that leave the molecule. It is the group of atoms or the type of atoms that give a distinguishing character to the type of elimination reaction. That may be hydrogen, that may be dehydration, that may be dehydrohalogenation, and so on. Due to this, there are two main methods involved in this type of reaction, that is dehydration and dehydrogenation. Like the substitution reactions, the elimination reactions are classified as E1 or E2, depending on the reaction kinetics. Similar to substitution, like in the substitution reaction, the SN1 reaction is those reactions in which in the rate determining step one molecule, that is the substrate, was involved. So here in E1 reaction, the reaction rate is proportional to the concentration of the substance to be transformed or substrate. In E2, similar to SN2 reaction, in SN2 reaction, as we know that there are two molecules that are involved in the rate determining step or the slow step. In E2 reaction, the reaction rate is proportional to the concentration of both the substrate and the eliminating reagent. The elimination reactions are also called beta elimination because it involves the elimination of a proton from beta carbon. When an elimination occurs, so one functional group leaves the carbon and the hydrogen leaves that carbon which is next to the functional carbon, which is alpha carbon. So the next one is called beta, and that due to this reason it is called beta elimination reaction. Then as a result it forms a pi bond and ejecting a leaving group. But there are some examples where alpha elimination reaction also occurs. Like here in this case, we see that alpha elimination has occurred from the chloroform molecule in the presence of a strong base. The chloroform has lost one halogen and one hydrogen, and as a result, we get a carbene molecule. But this carbene is very much unstable and energetic and reactive, and so it is transferred, it undergo further reaction and doesn't exist independently. Beta elimination, in which groups on adjacent atoms are eliminated with the formation of multiple bonds. Like here, if we see the halogen is attached to this carbon, and this is alpha carbon, while the next carbon, this is beta carbon. The hydrogen is removed from this carbon, and so it's called beta elimination. In the presence of a base, we get a double bond or unsaturated compound. Beta elimination proceeds through two mechanisms, which are E2 bimolecular elimination reaction and E1 unimolecular elimination reactions. They are similar. The E2 and E1 mechanism differ in the timing of bond cleavage and bond formation, and it is analogous to the SN2 and SN1 mechanism as we have already discussed. Thank you very much.